Okay. Hi, everyone. I'm Bhumika. I am one of the co-organizers of PyLadies Amsterdam. And just to give a short introduction, we're an NGO that supports women in tech by enhancing their Python skills, by helping them learn Python better and be better coders. And we think that's the best way to bring the balance back in technology. So today we have a really lovely and interesting session by Katarina about graph databases with GQLAlchemy and Python. And um, I will hand over the floor to Katrina in a minute. Before that, one or two quick rules. On Jit, this session is being live streamed to YouTube for those who are on the Jitsi. So if you do not want your video to be in the live stream, you can turn it off. And we are doing it this way because we want to encourage interactions. We want the energy to be nice and up. We're looking for engagement. So if you have any questions, drop it in the chat on YouTube, drop it in the chat here, or also feel free to unmute yourself and just ask a question. And we hope you have a good learning session and you take back something from this session. So, Katerina, the floor is all yours now, and go for
Thank
it.
you. Thank you, Bhumika. Like Bhumika said, you can ask whatever you want, whenever you want. I'm fine with that. So just jump in. So today I'm going to talk about an introduction to graph databases with GQLAlchemy and Python. So first, I'm going to give you a bit of introduction to the whole theme, like to the graph databases, to the
Hi
GQLAlchemy.
guys.
Hi. And then later on, I'm going to jump to the workshop in Jupyter Notebook, and we'll go through that. So yeah, first a bit about me. I was born. I was born at Croatian coast in the town of Šibenik. That is a small town. Maybe you heard of Zagreb, but Šibenik is a small town at the coast. So I did my master's in mathematics and computer science from the Faculty of Science in Zagreb. Currently, I work as a developer relations engineer at Memgraph. Memgraph is a startup, and I'm going to tell you a bit more about that later on. And I love to travel, cook, and eat tasty food, probably like everyone else. But yeah, check out my Insta. That's because I only publish my food, not only my food, but other people's food that looks pretty, because all food is pretty. Like, so yeah, you can check it out. So let's jump to the more serious topics. So a little bit about the graph data model. What are graphs and how to model a graph database? I'm not sure how many of you are actually familiar with this topic. So if you have some questions about that, you can just jump in, but I'm going to explain from the beginning. So what are graphs? On the right, you can see an image of the graph. This is called labeled property graph model. Why it's called that way? That's because we have a set of nodes and set of relationships, and the nodes are connected with those relationships, and each node can have a label. So this is why it's labeled. This label is here, for example, person or city and location. So some node can have multiple labels, and this is how we actually are filtering them in the database. Then we have this property part of the label property graph model. This is because each node and relationship can have a property. So these properties, for example, here, a person has a property name. This name is Harry on the left. So here. And also relationship can have a property. For example, married to has a property wedding date. So properties are some kind of key value pairs that belong to either nodes or relationships. Relationship connect these entities, these nodes, and maybe somewhere you have heard of vertices, edges, I don't know, points, links, different naming conventions. So this is all correct, but I'm going to try to use nodes and relationships, but I don't promise because edges will probably be there. Sometimes I just go with edges and then people go, what are edges? Yeah, these are the relationships. So sorry if I do this by mistake, but yeah, that's the same thing. So this is the graph data model. So once you have a data, and I'm going to show you that on a concrete example of the movies data set, but here we have a Twitter graph data model. So if, for example, you had a data set that has users that retweeted some other users, then you would draw this kind of graph. This is a graph data model that explains this whole database that you are creating. So you would have a node that is a user. So it has label user. It has property username, this type of string. And then user retweeted some other user. So everything in your database is actually connected, like user is connected to another user, and the connection, the relationship between them is of type retweeted. Yeah, I forgot to mention that. So nodes have labels and properties, and relationships have types. So this is not called label in relationship, but type. Here, our relationship doesn't have any property, but for example, we can have a property date, timestamp, something like that. So when this user retweeted another user, but here it's just not drawn, but you can have that in your database if you have that kind of data. Now, maybe you have heard of relational databases, so I'm going to try to explain a bit about the differences between these two databases and why would you use one and why would you use the other one. So here on the left, we have some example of graph database, and on the right, relational database. So in relational database, you have different kinds of tables, and these tables have some kind of primary key, foreign key, and they are not connected in the beginning, but you have to join these tables in order to connect them. On the left, you have a graph database, and this data is already connected. So each node actually has relationships that it is connected to. So this customer resides at location. This is all saved in the database. So this is like the main difference that you can also notice on these two images. So when would you even use these graph databases, and why not use relational databases? So when you have many-to-many relationships, for example, if you have, like in a Twitter data set, if you have many-to-many friends, like I am a friend of like recommendation systems for the social networks, for example. You have a person who is a friend of some other person who has a friend, and so on. So this is a very complicated connection, many-to-many. And in relational databases, that can get a lot of complicated, while in the graph databases, this gets pretty simple with the query language we are using. So I'm going to also show you that. So another difference is that when you have a relational database, you have certain schema which you have to follow. So you have a different set of properties which you need to have here, like column names, something like that. While in a graph database, you can have a different set of properties on each node. So you can have two location nodes labeled with location, and they don't have to have the same set of properties. So it's schemaless. So these are the main differences of graph database and relational database. So how do we even communicate with the graph database? There are many query languages, but the most widely adopted is the Cypher query language. You are going to see how that looks like, but it contains clauses such as match, delete, set, return. This is something similar to the SQL's select, join, where, something like that. It also has functions such as round. It has custom procedures, and these procedures can be written in Python, C, C++, and Rust. So when we are comparing the Cypher query language with the SQL, this is actually the query that does the same thing. It recommends some kind of product to one user. So on the left, you can notice that this query is actually a lot shorter than the one on the right. And that's because this kind of data and the recommendation system use case is much better for the graph databases. So on the right, you have to do lots of joins, while on the left, the data is already connected. So you are just traversing the relationships in this graph. So some use cases, I already mentioned some of them, but let me go through them. So I mentioned this one. This is like a social network. Here you can see that each user is represented with a node that is labeled with user, and it has a relationship, friends with to another user. And then with the help of graph algorithms, you can calculate, you can detect the different kind of communities, you can generate some kind of link predictions in order to recommend some friendship or something similar to that. Then also we are going to talk a bit more about this kind of use case. So this is a recommendation engine. This is some kind of movie recommendation because you have a user who rated some movie, and this movie is of some genre. So you can check which other users also watch the same movie and then recommend it to some other user based on that. So I'm going to show you that on a real example. Supply chain management. So this is something more this is some kind of business use case. So I noticed the question in the chat. So can we use this without the SQL? So so we are not using the SQL query language, but we are using Cypher. But I'm going to show you in the workshop that you can create it without using Cypher, without using SQL, without using Cypher query language, but with Python. And yeah, let me get back to you once I get to that part, because you're going to see that live. So let me just go back to here. Then fraud detection. Yeah, this is a good example where you can detect some kind of fraudsters. You can detect some kind of fraudsters that are doing the fraud. This is a card fraud detection. This is also a good use case. And then I think this image is really good because it's showing all the connections between the Facebook users. And actually, there is no map on behind of this photo, but these are only highlighted connections between users on Facebook, and it's creating the earth. So yeah, it's actually a pretty cool image. And this is like a graph because you have dots that are connected with relationships, and this is actually a graph. Okay, now let me jump into the Memgraph ecosystem and then also to the question in the chat, and I'll continue. So Memgraph is a platform for graph computation and streaming data powered by an in-memory graph database. Now, I said lots of words, and this seems like a complicated thing, but it's actually not. So actually, I held a couple of more meetups where I talked about graph-based stream processing. So what Memgraph is doing, it's actually doing some kind of graph algorithms on real-time data. And in this way, you can get pretty good insights of your data, but you can also use Memgraph as a simple graph database if you are not keen on some kind of real-time development. If you are, and if you heard of messaging brokers such as Kafka, Pulsar, something similar to that, then you can use Memgraph with them. But it is used to store data in memory, to run graph analytics, and to analyze streaming data. So it is a whole ecosystem. It's not just a database, but we built like a whole puzzle of things so you can connect to Memgraph with different kind of drivers. And maybe the most interesting to you would be this Python driver and also Mage. So I'm going to tell you a bit more about that. And this is where the GQLAlchemy comes. So GQLAlchemy is a fully open source Python library. It's an object graph mapper. I don't know if you heard of maybe object relational mapper. So this is SQLAlchemy for relational databases. And we have GQLAlchemy for graph databases. This is something we are currently developing. Recent release was 1.1 version, recent major release. And soon we'll have another release. And yeah, 1.2, we are really looking forward to it. It's close. But yeah, it has OGM capabilities, query builder, on-disk storage, and graph schema validation. I'm going to show you that, how that works. So query builder is actually the thing that we are using, so we don't have to use the Cypher query language to communicate with the database, but we can use Python code. This is still and always will be work in progress. So if anyone here is keen to open source contribution, you can always check our GitHub repository and make your contribution. We would be more than happy to have you help us. So next thing I mentioned was some kind of graph algorithms on our database. So I'm going to show you at the end of our workshop a little example of how you can do graph analytics in Memgraph. So we have a different set of graph algorithms. For example, the most popular ones are clustering and community detection, connected components, shortest path, PageRank, BFS, and DFS, and so on. And this is all developed inside our MAGE. So this is Memgraph Advanced Graph Extensions. This is also an open source repository, and it has different procedures written in Python, but also in C, C++, Rust. But yeah, you can actually develop different kinds of algorithms and contribute in Python. I'm going to show you how to use, for example, PageRank algorithm. But yeah, you can feel free to also check it out. It's an open source repository, so you can contribute. And to finish up this presentation part, this is the example where you can see that the graph analytics are really being used. Before I started working in Memgraph, I just knew about graphs in mathematics, because I did a lot of theory in graph theory, but I wasn't aware of the use cases. I wasn't aware of the companies that are actually using graph algorithms, and they really are noticing the strengths of graphs. So for example, Google, the PageRank I mentioned, Google implemented that algorithm to measure the importance of web pages. So when you are searching in Google, the top page that you get is the page that is calculated with the PageRank. Facebook, like I mentioned, in social networks, uses community detection algorithm. Then Amazon collaborative filtering. These are all really popular graph algorithms. And so on. You can see Pinterest here, Uber Eats, and so on. So there are many different companies that are seeing the value of graphs and graph algorithms. But yeah, let's do some coding. So now I'm going to switch to the workshop, to the Jupyter Notebook. So I'm not sure how many of you, let me just, I'm going to turn off my camera so that you can see the whole screen. And I'm going to just like this. Let me know if you don't see, if it's too small for you. I'm hoping that this is okay. This is what fits in my screen. Yeah, so you can find all these materials in the GitHub repository of PyLadies Amsterdam. Yeah, thank you, Bhumika. Yeah, I prepared everything in advance, so hopefully some of you maybe get a chance to install all the requirements. If you haven't, feel free to go with me. I will explain everything, hopefully in details, and just jump in if you don't get something. We can discuss it. If we don't manage to discuss it here, we can discuss it later on. So yeah, I'm going to give you a bit of introduction to graph databases, GQLAlchemy with Python, and let me tell you about what we are going to do. So we are going to learn how to create a graph model from a data set. So this is something like I showed you with the Twitter data, with the Twitter graph data model. So we are going to create a graph model, but from the movies data set. Then we are going to run Memgraph with Docker. Actually, I have already run it, but I'm going to show you how I did it. Then I'm going to connect to it from a Jupyter notebook. This notebook is already run, but I'm going to run all the queries with you again. with the help of GQLAlchemy, of course, and then we'll perform simple queries. I have prepared some examples at the end, some 5 simple examples, and after each example you have exercise, and I'm going to leave these exercises to you, but I have attached the solutions notebook so that you can always check that out if you have problems running it. Okay, so let me tell you, I'm not going to talk about the prerequisites, so hopefully you have installed it or will install it, but let me jump to Memgraph platform. So the easiest way to have a Memgraph on your computer is using Docker. So it is a Linux native application. So if you have Linux, you can install it natively on Linux. You can also install it on Windows using VSL. But probably, I think the easiest way is to install it using Docker. So if you are not if you haven't used Docker so far, that's not a problem. I mean, it's really not that complicated to start the app with the command I gave you. You don't have to worry about the details of this command. You can just start it like this if you have installed Docker for your operation system. But let me tell you about Memgraph platform. So I mentioned Memgraph and its ecosystem, so on, but Memgraph platform is the image we built in order for you to have everything in one image. So we also have a Memgraph image, Memgraph Mage image, but this Memgraph platform image is probably the best for you to install because you get everything. So with it, you get the database that holds the data, you get the visual user interface for running queries and visualizing graph data. You have MG console. So this is a simple command line interface, which we are not going to use today because it's Memgraph Lab gives you much prettier results than just a simple table. And Mage, this is what I mentioned, the graph algorithms library. Okay, so let me just show you how this looks like once I start Memgraph. So I have already started it. Here I had a couple of, okay, let me enlarge that. So I just put this command, which I already showed you. And Memgraph is running. So let me explain you a bit this ports. Okay, this is the command. So port 7687 is used for Memgraph for its Bolt connection. So it's using Bolt, not HTTP. And the other port 3000 is used for Memgraph Lab. So Memgraph Lab will be at localhost 3000, and Memgraph/Memgraph platform is telling us to start Memgraph platform image. This is the MG console. So here you can type your queries, but let me show you the Memgraph lab which we are going to use. So now all data was already imported because I ran the whole notebook, but we are going to restart that, and I'm going to show you how it looks like once it's empty. This is the Memgraph lab, which is actually getting its whole new version in I think in a week. Just one unpolished version, and then the next version will be. This next version will be a really huge change because it will have a whole new rendering engine. But this one will be due for our queries. So let me get back to the notebook. Other requirements are GQLAlchemy and Pandas, but Pandas is actually not a really important requirement here because I'm just using you to show you the CSV files. So this is not a problem if you didn't install Pandas. But probably if you are Python developers and doing some kind of data analysis, maybe you are already using it. Okay, so let me show you which data CSV files I have and what I'm going to do with them. So I'm going to start everything from the beginning just to check if the connection is working right and so on. So here we have movie CSV file. So this file consists of movie ID, title, and genres. So movie ID is some kind of special unique ID, and genres is it's not a list of genres, but it's divided with this with this line. But yeah, you have different kinds of genres that each movie belongs to. Okay. Then we have a ratings CSV file. And this file has user ID, movie ID, rating, and timestamp. So it's telling us which user rated which movie, which rating gave to it, and the moment when this user rated that movie. Now you can only see the user one, but this CSV file actually holds data of the, I don't know how many. Okay, we'll know how many. We are going to find that out later on. But since I'm showing only the first 5 rows of this table, then you are not able to see the other users. Okay, so like I said, we have a movie. Movie has a title, and this movie belongs to genres. So when I'm trying to do my graph data model, this is how I think. So movie would be some kind of node, and this movie would have ID, it would have title, and this would be its properties. And then it belongs to some genre. But I would like to have each genre as a unique genre. So, for example, I would like to have, okay, movie Toy Story is of genre adventure, but also animation. But I would like to have Jumanji to be also connected to this adventure, but the same adventure, so that the graph data model makes sense when you are querying it. So that's why I want to create nodes from these unique genres. And I'm going to show you that below. And here in the other table, you have user ID and movie ID. So user rated some movie. So I would want a user node, and it would only have property ID and rated some movie. Movie is already a node, like I said above. And then this rated connection relationship between them would have properties rating and timestamp. So like I explained here, this is where the graph model comes. Okay, so let me just, this is, so I already told you this what I said. This is written what I said, and here is the image. This is maybe more important than the text. So movie is a node, and this node has a label, movie. It has properties ID and title. User is also node that has label user. It has property ID, and user rated movie. So this is a relationship of type rated, and this relationship has properties rating and timestamp. I'm hearing something. Maybe someone has a question, or not sure. Someone is unmuted. Then movie is of some genre. So this of genre is actually type of the relationship. Okay, now let's go to the fun part. So if you have installed the GQLAlchemy, then you be able to run this. If you haven't, then install it with pip. This is a pip package. And it also has a prerequisite of CMake. So if you have some kind of warning, make sure to install CMake too. Okay, here let me do the import of Memgraph. What this actually does, it imports Memgraph, and Memgraph, we are going to create a new instance of Memgraph, and we are telling it it's running on localhost and port 7687. Like I showed you before, we have this running at this port. We started Docker container with this port, so that's why this will be available here. So we are creating an instance of our database. So first, let's drop everything in the database, and let me just explain now. So this is now, we started with the Python code. Like you probably noticed, in Jupyter Notebooks, we are always using a Python code. So here, this drop database is a method that is implemented inside GQLAlchemy. So with this simple method, you can do this. Usually, when communicating with Memgraph, you would have to do this with the Cypher query. So you would have to do match and return, match and detach delete and. So this is a simple way of doing this in Python. In these examples below, I'm going to show you the difference between Cypher and queries and Python code, so that you can maybe learn also something about Cypher if you are interested in that. So once I dropped the database, I wanted to check whether the number of nodes is 0. So here I did this with Cypher Query. I could have done this simple with GQLAlchemy. I'm going to show you below how, but yeah, this is another, I wanted to show you another feature we had. So whenever you have some kind of complicated query, maybe that is still not implemented with the query builder, you can then create a PR to GQLAlchemy and help us out, or you can use this simple method which receives this kind of Cypher query, and then it executes it and fetch the results. So with this query, we actually checked whether we have something in our database. Let me go to the Memgraph lab, and now you can notice that the number of nodes and edges, and here we have edges, not relationships, but yeah, you can notice that this number is 0. So the database is now empty. Okay, now let me show you how we define a graph schema in the Python code. And feel free to jump in if you have any questions so far. So to define the schema, we have to import some things from the GQLAlchemy. And this is where the object graph mapper shines. This is how it actually works. So we have classes node and classes relationship. This field part is actually from the Pydantic, so the object graph method of okay, I'm seeing the chat questions. So index types, okay, I'm going to get to that once I'm going to tell you this once I reach this part. So yeah, class movie node, what this actually means is that we are creating a new node. So it's inheriting from the class node that is implemented in GQLAlchemy. And it has two properties, one property ID, the other property title. So here we are using field. This field is from the Pydantic library. Pydantic library was used to build the GQLAlchemy subject graph mapper, and we are using it because we want to define some constraints. So this is the question from the chat. Here we are defining the index on this property ID, but it's also possible in Memgraph to create index on label. So just on movie, and you can also create index on ID or on title. So on any property or on any movie. You cannot create index, for example, on relationships. So hopefully that answers your question. Here we have only created indexes on our IDs because on property, because that makes sense, because when we are loading our data, we are connecting movie and users based on their IDs. So if you remember the table, we need to match these two. So if you want to do that fast, we want to create index on that property. In Memgraph, index are not there once you start it. So in order to work faster, index are added once you define them. So you have to define indexes in order to have them, in order to make this a quicker import or something like that. Sam, this is a good question. How would you create an index on node? So actually, funny thing, today I implemented that feature in GQLAlchemy, so I cannot use it and show it here. But how I implemented it, I can show you, it won't work, but I can show you how I implemented it. So I added here index true, and I added db memgraph. I needed to add this part db memgraph because we need to know on which database in the background we need to create indexes, because this all will be executed before you create an instance of this class. So this whole code will be executed before that. So we need to give it a database on which it will create an index. So this will work in GQLAlchemy 1.2. Currently, no. But if you want to create it, you can with the Cypher query. So this is not like a big issue currently. We just didn't make it in our previous version, but yeah, remember it for this version. So this is a good question. Yeah, so here we have index true, like I explained what that is. Unique is, we have different kinds of constraints. So unique and exists. Unique is that you cannot have another movie with the same ID in the database. Exists is that the movie node needs to have a property ID. So even though graph databases are schemaless, in this way, we are giving it some kind of schema. So we wanted to have a schema in order to do schema validation. So this is good if you are building the whole applications and you don't want to have different kinds of nodes. You want to be able to check whether you have the good properties, whether the data is loaded okay. So this is when you would use this schema validation, object graph mapper. Okay, so then we have a different set of properties. So we have a user, which is also node, genre, which is also node. When I'm giving this, it doesn't have any special properties. Actually, I think you don't even have to use this, but yeah, I used it. It's not a problem. And then also we have rated. So this is a different class. So this inherits from the relationship class. And as you can see, here we have also type. So what this is, we are telling it that inside Memgraph, we want it to be uppercase. That's because in Cypher, I mean, it would work with the lowercase and also like this. But in Cypher query language, it's common to do it with the uppercase because we would have type with uppercases and labels just normally. Let me show you. So like this. Okay, so how would the class of genre be defined if it was itself a graph? Let me just get that. So if it was itself a graph, a taxonomy of genres, I mean, it is a graph. So if you have just, I mean, here you just define the class, and when you create different instances of this genre, you would have a set of nodes. So once you have a set of nodes, this is also a graph. So graph doesn't have to have relationships between nodes. It can only have nodes. So actually, if you are creating only genres, you would only create instances of this genre node class. So yeah, is that what you ask? Oh, sorry, you ask the class of genre. Can you, if you can maybe turn on your mic and explain it a bit further if I haven't answered your questions because I didn't get that. Yeah. How would the class of genre be defined if it was itself a graph? Yeah. Yeah. You can tune in later if you want to ask. Yeah. Okay.
Katarina, we also have a question in the YouTube chat. Is there a way to design the database from drawing tool and export to code?
From the drawing tool to code? No, there is sadly no.
Okay.
Yeah, that would be great. Yeah, actually, I've written all this, so no. Okay, glad, Kat, to answer your question. Yeah, okay. Then hopefully I have told you everything about this class definition. And yeah, this is how you create a node, genre. And yeah, I also forgot to mention, here you can also have some kind of label that is different from the class name. So for example, if you want to have a class name that is something that it's good for you. So for example, you want to have class name movie, but in Memgraph, you would like to have a label that is different, right? Say film. Then you would put it like this. So we are letting you to decide which label you want to have. It doesn't have to be a class name. But if you don't give it anything, then the class name will be. Also, like I mentioned on the image with the location and city, you can have multiple labels. Then we have labels, and these labels, so we are defining it as some kind of set of labels. So let's say film and movie, then your node would have movie and film label. So yeah, you can also do this. Here I just put some kind of simple database, and I didn't want to complicate, but yeah, you have different kinds of options here. Let me run this. Okay. So this, I already told you everything here, but it's better that it's written if you go here afterwards. Let me now show you how I'm creating an instance of some node. So for example, I'm creating a user and I'm creating a movie. I'm saving it to Memgraph, and I'm going to show you how it looks like. So this is a spoiler alert, but okay. I'm creating a user node by creating an instance of user. I'm giving it an ID and name Katarina. So for example, here I have Katarina and movie Lotter, like Lord of the Rings, of course. You can notice also here that the IDs are the same, but this is not a problem because this will only be a property, and we don't care because this one is movie and this one is user, so it's not a problem of uniqueness or something similar to that. Then we are saving into Memgraph just by going .save Memgraph. There is also another option, I think. I'm not sure whether this. I think this is also implemented, something like memgraph.save node and then user node, and also for the relationships. But yeah, this is maybe more, I like this better. So we are saving this two nodes in Memgraph and printing it out. So let me show you in the database. It says that we have two nodes, and now the infamous cipher match. I'm saying infamous because I don't know how many Python developers like cipher, not sure, but it's not that hard. It's actually pretty intuitive. So with these parentheses, I'm saying that it's a node. With this kind, I would say it's a relationship. So this is a node, and I'm returning this node. I'm saving it into the variable. So I want all nodes in my database, and it's here. So we have a movie, we have Katarina, great. And why is this movie and not Lotter? Well, because we have a graph styling language, and here you can fix it. So let me check where to fix it. Oh yeah, that's because our movie has a title while our user has name. So I need to set it to title here. Okay, title. And then hit apply. Yeah, that's it. So now it looks the same. Okay, so you see how to save nodes in the database. And this is when we print it. This is actually showing us that that it is serialized well. So it's recognizing that this is an instance of a user and this is an instance of a movie. So what is this ID? This ID is the internal Memgraph ID that is given to the nodes upon saving. So once you save it to Memgraph, it creates internal ID that helps it find data. So it's not the same as this ID because this ID is only the property that we are giving to you. You didn't have to save this ID if you didn't want. I thought this would be easier to understand. Also, here we have labels. It only has one label, so it's just a user and its properties. Okay, now let's try to create another node, and let's also call it Katarina. So I'm going to show you that you cannot create another node that has Katarina, and that's because we have defined it in our schema that it is that this node cannot exist again with the same name. So yeah, it cannot exist. Okay, next, let's try to create the relationship of type rated between the, okay, so I want to create the relationship between Katarina and Lotter, and I want to say that she rated it with 5.0. So timestamp, I just gave it here so that you can notice that you can use, for example, time library, Python time library, and then you can give it like a property. So let me remind you what this is. We are creating this part. So from Katarina, that is user, we are creating a movie. We are creating a relationship called rated to the movie, Lotter. Okay. So let me skip to that part. Sorry for scrolling so much. So we are creating an instance of rated we are giving it we are going it user node ID, end node ID, and rating. Okay, and timestamp. So we are saving it to Memgraph and printing it out. Let me check whether this loaded properly. Yes, it did. And how to check it actually inside the database. So we are matching some node relationship to some, this is the direction of the relationship. We are matching it to some other node. These are variables in which we are saving this. And we are returning these three. I want to see how this looks like. Okay. Great. So Katarina rated the movie. This is the rating. This is the timestamp. And this was the data that we have. Okay, so this is how we can create a simple two nodes and the relationship between them. But let me now jump into the real data that we have in our CSV files. And because of that, I'm going to drop the database first. So we are back to 0. And then we need to, download the movie CSV and rating CSV files if you haven't. And we need to copy it to the Docker container we are running Memgraph in order to, so that Memgraph can see those files. I'm not sure whether I already did that, but I think I did. But I'm going to show you how you can check out what you have in your container. So let me go here. Yeah, so let me just enlarge that. Okay, this is the wrong terminal. Just a second. I'm going to open a new window. Okay, so just a second. Let's see what we have running. So with Docker PS, you can see all the running containers. Currently, I only have one running container, and this is memgraph/memgraph platform. Okay, so this is maybe, not sure whether this is better, but okay. Let me know, Scream, if you don't see. But this is the container ID. So this is some unique number to the container which you ran. And you can, with the help of this container, check out the contents of your container. So you go docker exec it, then container ID and bash. Okay, we are inside the container. And here you can see everything that it's inside our container. So as you can see, I already copied the movies and rating CSV files. I wanted to check that out. So here we have movies, we have ratings. Here you can check out Memgraph logs. So you can do everything you want inside Memgraph. You can see the configuration file. You can see the major procedures and so on. But let me exit this. And if you want to copy your data now, you can do it by running these two lines. So since I already copied, I don't have to do this again. So you are running this from outside of your container. So now, once you exited your container, or if you didn't even enter, you are running this Docker CP. So this is Docker copy. So you need to locate yourself inside a folder where the movie CSV and rating CSV files are. And once you are located here, you run this command where the container ID is the container ID which you find out with the Docker PS command. Okay, so you can copy these two files, and this will help you in loading in Memgraph, seeing those CSV files. So we are going to import this using load CSV clause. Actually, I did this with the Cypher query. Not sure why, because I know I implemented the load CSV command with the query builder. But maybe because this is still a complicated query, but yeah, I could have done it with the GQLAlchemy, but it's actually pretty the same. I mean, you would have you would have to call load CSV method and then give it this movie CSV argument and probably row, and then merge command and so on. So you are actually building this query. So it's, I mean, you are using Python code, but you would have to be familiar with some kind of Cypher logic. But actually, it's really not that difficult. So for example, here, we are saying it load CSV file from this CSV. Here we are telling it that it has a header. So it has a header because it has that movie ID, title, and genres headers. So it's like a column names. And we are telling it to open it row by row, and we are reading it row by row. So on each row, we are merging. What merging means is we are not creating, but we are merging. This means that whenever you have the same movie, if, for example, you have a table with the same rows, you don't want these rows to create another node, but you would want to merge with the existing node. That's why the merge clause. So we are creating a movie that has an ID, that has, and also title. And then with this movie and with this row, we are creating genre. So we are splitting that row that had those lines for genres. We are unbinding it. This means we are actually creating some kind of list from these genres that have delimiter, this delimiter. And we are creating, that is merging, our movie with the genre that has a name that is a genre, and creating a relationship between them that has a type of genre. So yeah, we have from this movie CSV file created a movie label, node labeled with movie. We have created node labeled with genre and the relationships between them. So we have created all movies, all genres, and all relationships between them with this one query. Yeah, I'm going to run it. And next thing, I'm going to check this inside, here. So it's filling up. And the other thing we have to do, all that is left to do is we are creating user nodes. So we need to connect existing movie nodes with the user nodes. So we need to load CSV from rating CSV with header as row. It's exactly the same thing as above. And we need to find the movie from that table that has the ID from that table. And we need to, once we find it, we need to create a relationship between that movie and the user in that row. And in order to do that, we first have to create the user. And after that, we have to merge that user to that movie and create the relationship between them. I'm not sure why is this so slow now, because maybe I have some other process running, because usually this takes just a couple of, it takes 1 second. So let me check. Let me check the status of the running Memgraph. Just a second. Yep. So yeah, probably it would be best if I restart the whole notebook again. Just a second. Because we haven't connected. We connected a long time ago. Let me see. Yeah, I have some kind of issue where nothing is running. Okay, that's fun. Let me check. Maybe internet connection. Yep. Okay. Something is happening. Yeah, usually this goes. Oh yeah, now it's done. All. So yeah, I probably had some internet connection issue. Something. No, not internet, but some issue. Okay, let me get back to where I were. Yeah, this was done like in 1 second. I'm not sure why that happened, but now you can see that all data is loaded in Memgraph. And just to show you a bit how this looks like, I'm going to do something like this, but there is a lot of data, so I'm going to limit this to like 10. Sorry. So this was the wrong ending. Yeah, so like movie was rated by a user. Yeah, I needed to tell. Okay, so let me give you a whole example of a user that rated the movie, and this movie is a part of some genre. So like I said here, we would have another relationship here, and we would have, sorry, this arrow is not here, but it's here, and another node. But here we have to say, okay, I want user that is so user that rated, I think. a movie. I forgot R here. And this movie is of genre. And this is some genre. And let's say O here. Okay. So I want back N R R M O G. And this. Okay. I think this is it. Okay. Let me give it a bit of more. Okay. So what we have here, this is some movie that is of genre adventure, and this movie was rated by some user. Okay, this user only has user only has ID. My user had a name because I gave it a name. So yeah, so that's actually it. Okay, now let me
Katrina, we also have a question in the YouTube chat about how is the node ID and relationship ID getting assigned? Is it just a random integer or is there an ordering to it?
Okay, so I think that it has an ordering. So you would have, for example, I think there is also when you are creating two nodes of the same label, I think that the ID is like 2, 4, 6, something like that. So, but it's going like 1, 2, 3, 4, 5, 6. So it has an ordering. It's not a random integer. It's always ordered, but when you are creating I don't know, you created something, you deleted something, it won't start from 1, it would start from the number where it stopped, but it will also go by some ordering. Yeah, that's how the internal IDs are.
Yeah, because the question mentioned that the node object ID is differing by 1, but relationship ID is a different integer that's not differing by 1, so the difference was a bit different. So is there a
this is
reason
like a
for
big
that?
number, right? That's because that happened. That actually happened because I saved it. Let me just check what. Yeah, la la la. Let me check this and this. That happened because I restarted this notebook lots of time, but it has a certain counter for the relationships and certain counter for the nodes. But this one, you see, has an ordering because this one was saved before this one. But the relationships have another ordering because it's not important, because inside Memgraph knows whether it's a relationship or node. So it's not a problem that those two are not similar, but the new relationship behind this one that would be created would have following ID.
Okay, that's clear. Thank you.
Thank you for the question. Once we imported our data, we saw that everything is imported. I'm going to show you how you can get some kind of simple queries. And like I already told you, we are using Cypher query language. You have lots of different clauses you can use there, and these clauses are actually also used in Query Builder. So match, where, return, union all, unbind. And like I already explained, for example, here you are matching, you are finding a node that has a label movie, and you are returning it, and you are ordering it by the title of that movie in ascending order and limiting by 10. So here we have a result. Once we run this, we need to put it in the list in order to iterate over it, and we are printing the result. And here M is because we returned this variable name is M, so it's remembering this variable name. And here we have these movies. Would you show how to query the timestamp? Yeah, we can do that. Okay, let me get back to that. Not sure. Let me check. No problem. Oh yeah, so we have a timestamp. La. Okay. Okay, now I need to. Yeah, let me just remember whether this would actually. This is a good question because we have a date time type inside Memgraph. And I know that date time works. Yeah, I deleted this. I deleted this. Let me check some other timestamp. This one. Yeah, so once you are querying it, it will be saved as a float. So because I defined it like a float in my schema, that is because Memgraph cannot save a timestamp like a native timestamp from the Python, but it can save a date time. So here I use timestamp because timestamp was in the data set I had. But the better thing would be to transfer it to some kind of datetime and then to use it as a datetime object inside Memgraph, and that is possible. And then when you get it back, you don't get the float. You don't get the float in Memgraph or in Python, but you get the actually what I actually need to do. I can do this with this query, but maybe it would be prettier. Okay.
We're back live.
Great. So yeah, I'm actually trying to find some. Let me check this. So what I'm trying to do is I'm trying to filter it by the timestamp. Actually, I don't think I need this. And this timestamp is oops, I didn't want that. It's a float, so it's a number. I would like it like this. Match this, so rated. I want to return this, and I don't want to limit it because I'm expecting just one result. Actually, I don't know if it's one result, whether I'm going to. Okay, I'm going to say it. Let's do it like this. I'm not sure whether there are ratings that happen in the same moment, but I would say no, not sure. I didn't. There are lots of data in this data set, so I'm not sure. Okay.
Yeah, probably not down to the second. So
yeah,
we'll
probably
find
no. Yeah, hopefully no. Let me just now do this. So result. Result. Let me check whether this works. If not, I'm going to. Yeah, of course, not working because I. Okay. Let me just first check the query because this is now probably Python related. So you can help me. Nope, I did something wrong. Let me just check the query again. Maybe I have to add this, and this. Yep. Okay, there are two. There are two of those. Yeah, I have a duplicate. This is actually. This means that I haven't merged it. Okay, this is a good thing I found this, or maybe I restarted something. Okay, this is a good finding actually. So it's good that you asked me this. I need to check this out. Why this happened? But yeah, let me do this. Oh, you always find some kind of bug when you are trying something like this. But yeah, this is a bug and I will need to explore it further on. So I expected to be one. As you can see, this is the same node and this shouldn't have happened. And why this happened, I'm not sure. So I need to explore this. But yeah, this is how you would match this. I think that you can also do this. You can also do this with Query Builder. So this would be something like match node. I will write it how it would look like. So you match node 2, and this 2 is a relationship. So type of this relationship is rated. And then you need to also give it some property. This property is timestamp. I think it's like this, and then you give it this value. And then node. So you are actually building this block, so matching this, and then return. And this is with the underscore because of the saved word in Python. And then you have to execute this. So this is how you would write it. I think this is how you would write it in a query builder using GQLAlchemy. So I hope that, I mean, you helped me. I didn't help you with the question. I think that I certainly need to explore how this happened. But yeah, we have lots of more exercises here. So I would jump to them, and then maybe later on we can check it out what happened. So I hopefully this answered your question with how to search for the relationship that happened at a certain moment. Okay, so let me see where I stopped. Okay, somewhere here. Okay, so I showed you the movies and then ordered them by title in ascending order, limited 10. So I'm showing you the first 10 results of the movies. And here I'm showing you that they know that they are movie class from Python. So you can see that you can read their title in the same way you can read their ID. And yeah, here I showed you how you can actually use Query Builder for the same query. So here for this query in Query Builder, this is this. So match node. This node has label movie labels. I mean, it's a bit confusing, but you can use both. If you only have one label, then you are giving it to the variable m, and then you can use this variable later on in the query. You are ordering it by the title. So now you can use this m because you have variable here in ascending order, and giving it a limit and executing the query. Once you execute it, you can get the result back. So this is the same result as above because we actually created the same query. In the background, what we do in GQLAlchemy, so we have methods in the query builder with these names. And we are building step by step the whole Cypher query. So when you do match, we are creating a match clause. Then you want to match it to node with this label. So we know that we do m, then this delimiter, and then movie. So then we return the results and ordering it by this and just limit 10. So you are creating a clause with the uppercase limit and so on, and we are connecting all that. And once the query is executing, it's actually being executed inside Memgraph. So yeah, what we aim to do in our next releases, we want to do check here. So currently we are letting you to write however you like, but you would get an error from Memgraph if you write the wrong query, like I got before. So usually what we would want is that you know that you cannot do something like, let's say, this. Yeah. But in order to do that, we want to check some state of and remember the list of all these parts of Query Builder, and maybe then check whether you did the right thing. But we would need to implement something like check the whole grammar here, something like that, of the Cypher query language. So yeah, this is yet not implemented, but yeah, one day maybe, hopefully, if you have enough time. Yeah, so let me show you now something that is maybe more interesting. So what you can actually find out from this database, why is it even useful? So for example, you want to find out how many users there are in the database. So you are actually looking for how many nodes have this user label. So you are filtering by this label and returning the count. This count is a function inside the Cypher query language. It's counting all the nodes, all these variables, and returning it as a num of users. So yeah, we can try it out in at Memgraph lab. This is the number of users, 610, and here how we did it with the GQLAlchemy. This is like a dictionary where you are telling it how to return which is the name of this as alias. So this is, you are actually giving it the key value pairs, which will be in the return. And in the end, you also have the result 610. So the exercise here would be, how would you find out how many genres there are in the database? So yeah, I won't give any hints, but yeah. Let me check the question. The class returned by typem is not the one you explicitly created at the beginning. I assume it's a class created by Memgraph when you loaded the file. Sorry, I'm a bit confused. Okay, sure. Let me go there. No, this is the class I created. So yeah, this is an object graph mapper. This means that once it's back from Memgraph, it recognizes that it is a movie class. So it's not from Memgraph, it's from Python, and it's a class we created. So in the background, there are lots of meta classes. We played with it a lot. So yeah, I'm working on it. I'm still figuring out lots of part of that code. My colleague started it, and I continued on it with my other teammates. So hopefully I answered the question okay, but you can always check out the implementation on our repository. So yeah, this is actually the Python class I created. Okay. So next example would be, how many users rated the movie with the title Home Alone? Yeah, so we are matching the node. I'm going to skip the Cypher query. Maybe this part would be more interesting. So I'm matching the node labels user and variable u and a node to node. So relationship between them is rated. Other node is of label movie, other variable. And then I want to see where this title equals to this title. Okay, so in the end, I want to return this count of views, so number of users, how many users rated the movie with number of users. And the answer is 116. Okay, so for the exercise, you can find out how many genres the movie matrix is connected to. Why I'm asking this here, we try to find how many users rated the movie. And here I'm asking how many genres the movie matrix is connected to. That's actually a very similar query, but actually only the difference is in the relationship and node type, in the relationship type and node label. So I think that you'll manage to do that with the help of this query once you get this query. Third example would be to find the genres the movie Blue Lagoon is connected to. Okay, so we want to find the genres that, so first we need to find this movie. How we are going to find this movie? We are going to find it by its title, and then we need to check the name of all genres that it is connected to. Okay, so we want to match node to node. This first node is a movie node. It is connected with the of genre relationship to node that has labeled genre, where the title of that movie is Blue Lagoon, and then we want to return the name of the genre. And this name of the genre is adventure, drama, and romance. It has actually 3 genres. So yeah. Is it possible to display the graph within Jupyter? So yeah, I haven't tried that, but if you know some good Python library that can draw for example, I just drew graphs with the help of the JavaScript library called D3JS, and I use that, of course, in JavaScript. So I use that in some kind of React application, and it was only necessary to have circles and links between those circles. So if you know for some about some good Python library that holds good data, that can draw data based on circles and links, something like that, I think that would be enough. I haven't used it, and if you know about some library that can be good for this, you can tell me. That would be a really good addition to this workshop. Okay, so next we want to find out the title of the movies that the user with ID 1 rated. So we are filtering let me check. Oh, no, sorry. I was really, so this is the exercise. Yeah. I was checking this cipher query and I don't notice this isn't the solution, and I was looking at it. Why? So yeah, find out the title of the movies that the user with ID 1 rated. So this is actually the same type of filtering, but just with the different kinds of nodes. So you want to find out all users that have ID 1, and you want to check out their connection with the movies which they rated. So yeah, I'm not going to spoil it, but it's actually pretty similar to this one. Then I want you to list 10 movies of comedy and action genres and sort them by title. So we are looking for a movie that has a genre action, and this movie, we want this movie to also be a comedy, and return this title, order it by title. So I think that the this ordering is it ascending? Yeah. So we have descending and ascending ordering, and limited by 10. So we only want 10 results. This was a cipher query with GQLAlchemy query builder. This is like, I mean, actually, as you can see, cipher query is maybe even a shorter query, but yeah, this is, we need to build this like this. It's really hard to do it shorter, but once you get used to it, it's not that hard. So node to node, movie to genre, we are checking it whether it's an action, and then we are matching again this movie to another genre that is a comedy and giving back the title. And that's it. Then you have to, for the exercise, list 15 movies of documentary comedy genres and sort them by title, descending. So this was ascending because by default, when you order, it's an ascending ordering. But if you don't give it another ascending or something like that, it's ascending. But if you want descending, you need to add des. So I had that in one example before. So this is a bit of difference. And also the genres are different and the limit is different. So yeah, work on that. And next we have an average rating of the movie Star Wars. How to find an average rating. This is actually not that hard because we have a cipher function called average inside the cipher query language. So you can find the list of all supported functions in cipher manual. We have different kind of things for lists, strings, and something similar to that. So we just get this average rating. And like we matched before, we are matching user to the movie and getting the average rating. So we can notice that the Star Wars episode 4 was, its average rating is 4.2 out of 5. So I would say that's maybe even low, but yeah, pretty expected. So we, in the exercise, fun thing, minimum rating of the movie Star Wars episode 1. So you would be surprised. Okay, so I'm going to do this part a bit quicker because we are short on time a bit, but also this is maybe if you want to know more, maybe if you want to play with some more advanced things. I know this is a beginner, so this is a beginner lesson workshop, so I'm not going to go into details with this. You can read it later on, but I just wanted to show you that this thing can get a bit complicated and that you can do complicated things in this, which I like. So you can implement also collaborative filtering that is used for a recommendation system. So this is, for example, one kind of movie recommender. So here, for example, for some user with ID 608, this is some existing user in the database which I chose, we have a predicted movie which this user would like. So this is a list of the movie, and this is a prediction rating. So this would be the most predicted movie, and so on. So now you don't know which movies this user 608 watched, so we don't know. I mean, you can list that, but currently I don't know whether this is a good prediction, but it should be based on this memory-based collaborative filtering. So here we just use the formula formula from that way of collaborative filtering. Also, so here I explained in detail, so you can look that further on, how this actually works, the parts of this query, what actually happened in this. But you can also use another type of, different types of recommendations, similarity functions that are being calculated. For example, Euclidean distance. So then you would have this part as similarity. So here above in the Cypher query, here we have, this is for memory-based collaborative filtering, and for Euclidean distance you would have something like this. So it's also a bit complicated, but yeah, this is how you can actually have a recommendation system inside your Python code. Yeah, just getting it from the graph database.
Are there like shorter ways to write this with the API? Like, for example, that I don't have to write the whole Euclidean.
Euclidean, you mean if we have implemented that?
Yeah, say like
similarity.
I put like node execute return, and then I say like Euclidean distance.
Actually, I'm not sure whether we have implemented that Euclidean distance, but if we had, it would be placed inside the Mage library, or you can implement it by yourself, so you can have it and reuse it.
Yeah, would be interesting, or even this one, if not the Euclidean, because but this one for the collaborative filtering would be interesting if it's like built in and you can just call a function.
Yeah, I can check it. I can check it later on and let you know. I'm not sure whether we already have it so that you can use it, but if not, you can always like copy this query and you can have it in your code and then have a function called, I want to do collaborative filtering and reuse it. But yeah, that would be good to have it already inside the Memgraph or its Mage library. I mean, maybe it already is there, I'm not sure, but I should check it out. Yeah. But
yeah, that's just more curiosity. Yeah, more curiosity indeed. So thanks.
Yeah. Great suggestion. If we don't have it, it's a great suggestion to have it. Yeah, I agree. And then in the end, I wanted to show you a bit what we usually do. So this is not some kind of real-time example with the real-time data. This is with a static data, but I can show you what Mage can do. So Mage has this kind of procedures called PageRank, between a centrality, something similar to that. So you can do different kind of graph analytics. I already told you what PageRank algorithm is. So it actually outputs probability distribution to represent the likelihood in Google that a person randomly clicking on links will arrive at any particular page. So if you are checking our data set, and if I am calling a PageRank on movies, the result of that PageRank algorithm would actually be some kind of popularity of that movie, because I'm checking, it's actually calculating the probability that on a random walk you would get to that node. So it has lots of connections surrounding it. So yeah, here we need to use another method from the query builder called call. This is used for calling the inbuilt procedures inside Mage. And we are actually, after call, you need to have yield. So we are calling PageRank. This is a module, and this is a method inside this module. And we are not giving it any special arguments. It can have different kinds of arguments, but I'm just calling PageRank. And this node and rank part are what it returns from this. I'm calling it the same, so node as node, rank as rank. And yeah, this is a bit of hack which we added because yeah, actually in a new version of GQLAlchemy that will be released in a week or two, this won't be a hack anymore. This would be where and node, this delimiter, and then movie, because we implemented this. This wasn't implemented in the previous version because, to be honest, we forgot that we had where and then filtering based on the label. So yeah, that won't be custom cipher, but this is a good thing because whenever we forgot something, we can use this and then implement it later on. And then we return this node title, as movie title and rank as rank, and order it descending because we want the largest page rank to be the first one, and the limited 50 just to get 50 results. So here I'm actually doing the page rank on the whole network, but I'm just filtering on movie nodes. Okay, and in the end, Shawshank Redemption won. So it's, I would say, I think that also on IMDb, it's the first one or the most watched. Not sure. Is it the better rated? I'm not sure, the best rated movie, but here in this data set that I have, it's also the most popular movie. So yeah, you can see this is some kind of a list from the best ones. And on the right, you can see this calculated page rank. It's pretty small. It's a value from 0 to 1, since it's a probability. But yeah, this is fine. This is an expected value, I would say. Like if you have a good network, yeah. So this is like 0.00000. And that's it. Yeah. Hopefully, you gain some knowledge. I know that this is actually the first workshop I am presenting. So hopefully I explained what I could, what I couldn't, and the mistakes I noticed. I will make sure to fix them and let you know how we can fix that. And yeah, the solutions to the exercises are located in the other notebook, which is in the GitHub repository of the PyLadies Amsterdam. This is the solutions. I put Cypher queries and query builder here so that you can have both. Hopefully you will try solving this by yourself before looking at the solutions. And yeah, thank you, Kat, thank you. I hope this was okay. But yeah, I need to finish with the presentation. I think what we learned, hopefully, how to use graph databases, what is Memgraph, how to create a graph model, how to load data, how to use GQLAlchemy, and that we can perform different kind of graph algorithms. Thank you all for your attention. If you like what we do, what I do, throw us a star. I mean, the star on Memgraph repository is maybe the most valuable star, but I am also keen to GQLAlchemy since I'm working on it. So you can contribute, give it a star. Feel free to let us know what you think about it. It's a work in progress, so your suggestions are more than welcome. And if you want to talk with us, get to know Memgraph, whenever you get stuck with it, you can join our Discord server. We are always hanging out there. And yeah, these are my contact information. So if you have anything to say to me, or yeah, you can do it now, you can do it later on. And that's it. Thank you.
Thank you, Katarina. It was a really good workshop, and thanks. I would not have guessed it was your first one. So yeah, you did a really good job.
Thank you. Yeah.
And we have one question in the YouTube chat that might also be a good winding up.
Mm-hmm.
So why use Memgraph over other over other graph databases? And I would also add what would be the strengths of Memgraph that would make it better for certain use cases.
Mm-hmm. So there are other graph databases. Probably the most popular is Neo4j, I would say. People are using it a lot. But we are concentrated a bit on different things. So as I emphasized, we are a streaming graph platform. So it's best to use Memgraph when you have real-time data that you want to calculate on graph analytics on. So we have great implementations of graph algorithms in C++ that is pretty fast. Memgraph is also implemented in C++. Memgraph is an in-memory graph database, so it makes these calculations pretty fast. So this is its advantage. It's not there to be a source of truth as your graph database, but it's there to perform different kind of graph analytics. So I would say that in the world of graph databases, the biggest one are concentrated to be substitute for relational databases, but we try to be something different. We try to get this niche of streaming graph analytics, and you can build your applications, whole applications, with the help of Memgraph. pretty fast. I built a couple of demo applications showcasing real-time examples. You can check that also on our GitHub. We did this Twitter data set. So I did some kind of real-time visualizations where the nodes are changing their sizes and so on. So I think it really shines in the real-time graph analytics.
Okay, thank you. That's really interesting. And yeah, and I also had another question that I think might be useful for you as well. So since the community is open source, how can I, as a developer who's just completely new, contribute to the community and get involved?
Yeah, so you're talking about the GQLAlchemy
About
and Mage
GQLAlchemy.
contribution. Okay. So we have a contribution guide on our repositories. So I think Mage has a totally finished contribution guide where everything is, I can send you the link, where everything is written. We are currently working on a contribution guide for the GQLAlchemy since it's pretty new. And hopefully we will finish it. But yeah, if you have any doubts, so we would be very happy to see your PR if you are interested to it. You can check out the issues. So we are trying to make a good first issue. It has labels good first issue. So if you want to contribute, you can always start with some good first issues. We're trying to create it as much as we can, or you can just check it out and create an issue. Think that something could be done better. A lot of contribution is actually just creating an issue for us. It's also, we are very welcoming to that too. So yeah, whatever feels right. I can send you the contribution guide of the Mage repository, and it will be similar at the GQLAlchemy repository.
Okay.
Yeah.
Yeah.
For any questions whatsoever, you can contact me or you can join the Discord server, because we are always hanging out there. It's our little community and sharing the courses, materials we have, events, and everything there.
Okay, that's really nice. And yeah, we hope that you get a few PRs from our side and from our community. And
that would be amazing. Yeah, at least issues. I mean,
yeah,
that would be also awesome. Yeah. But yeah, we will have a new version. On GQLAlchemy, we are actually working on develop branch. So we have main branch and develop branch. And on this develop branch, there are whole lots of new things. So if you are checking it out now, you can check out the develop branch. So if you're creating some issue, maybe in a week or two would be a good time to check the new version with the lots of new fixes, I would say. So yeah. Sadly, I couldn't have used this version because we are publishing on PyP like every time we have some kind of major release. So yeah, this one is still not out.
Okay, that was it from my side. If anyone has any questions, feel free to throw them in now. And otherwise, we are, I think, a few minutes over time. So we'll close the session, and feel free to contact Katarina or reach out to any of us. And yeah, we hope you had a nice time learning things, and have a lovely evening, and see you at the next session.
Yeah, thank you all for joining.
Thank you.
Thank you for joining. Hope you learned a lot. Good night.